loop in Java, so sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Hey, what's going on, guys and gals? In this video, I'm going to explain the for each loop, also known as an enhanced for loop. This is a traversing technique to iterate through all the elements in an array or other collection. The benefits is that a for each loop takes less steps and is more readable than a standard for loop. However, it is less flexible. So let's begin by creating an array of animals. So these will be animal names, so the data type will be string. Then we need a set of straight brackets. We will call this array animals equals, and then we will assign a few values. So within our array of animals, let's say we have a cat, a dog, a rat, and a bird. I'm not sure what kind of bird, just use your imagination. Now we could create a for loop to iterate once through each element of this array, but we could also use a for each loop to do this. So this is how to create a for each loop. Type for, a set of parentheses, and then a set of curly braces. So the only part that is different is the statements within the parentheses of the for loop. We're going to begin by listing the data type of our array or other collection. So we're going to list this as string because we're iterating through strings. Next, we need an index. Let's say index I, then colon. Colon represents the word in. For every string index in our array of animals. So lastly, list the array or collection name at the end. So this will iterate once for each index in our array of animals. So what would we like to do within each iteration of this for each loop? Let's display whatever I is. So this is going to be a string, whatever this data type is, so we can print this directly. And when we run this, our for each loop will display all the elements within our array. And now let's try this for each loop using a collection. An array list is a type of collection, so let's create an array list called animals this time. So array list, within angle brackets, we're going to list the data type, which is string, and then we will call this animals equals new array list, angle brackets, list the data type, parentheses, semicolon, and then we'll need an import at the top, import java.util.arraylist, and then we need to add some values to each element of this array list. Animals.add, we're going to add a cat, then repeat the process for dog, rat, and bird. Dog, rat, and bird. And you can see that nothing has changed. So remember, a for each loop is useful for iterating through all of the elements in an array or other collection. It involves less steps and is more readable, but it's less flexible compared to a standard for loop. So that is everything you need to know to get started with the for each loop, also known as the enhanced for loop. If you would like a copy of all this code, I will post all of this in the comments down below. And don't forget to do me a favor and smash that like button. Drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on, everybody? It's your bro, hope you're doing well, and in this video I'm going to explain methods in Java, so sit back, relax, and enjoy the show. You can become a hero and save our channel by smashing that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Alright, welcome back, guys and gals. In this video I'm going to explain methods. A method is a block of code that is executed whenever it is called upon. For example, when we begin our program and execute it, we begin by calling the main method. That's where we've been writing a majority of our code. So anything within this set of curly braces belongs to this main method. This time we're going to create our own method that we can call whenever we need it. So outside of our main method, make sure you don't write this within the main method, we're going to create another method, perhaps a method that will display a message such as hello. And to begin creating a method, we'll need a return type. I'll explain return types later on in this video. For now, we're going to list the word void, followed by a method name. Our main method is called main, and a common naming convention for methods is to have the first letter lowercase. So let's create a method called hello. When we call this method, it will display a message such as hello. So this will be hello with a lowercase h, then we need a set of parentheses, and then a set of curly braces. Anything within the set of curly braces belongs to the hello method, and if we call the hello method, it's going to perform whatever code is between these two curly braces. So what would we like to do when we call this method? Let's display a message such as hello. Now within our main method, we can call, also known as invoking, this method. So within our main method, we can call the hello method whenever we want. Now we have just one issue that we need to take care of, and let me explain. We cannot make a static reference to the non-static method hello from the type main. So this means that we need to precede this method with the keyword of static, because we're calling the hello method from a static method of main right here. So normally we do not need to add this keyword of static, and if you want to learn more about things that are static, I do have a video on it. But for now, we just need to add this keyword in order for this program to work for this example. So when we call the hello method, it's going to perform whatever is within our block of code. And here it just displays the word hello. And we can call this method whenever we want and however many times we want. So if we want to display the word hello 3 times, we can just call the method 3 separate times. And this method will perform its task, its block of code, however many times it is called. One feature available to methods is that we can pass a value or a variable to a method when we call it. For example, we can pass a string variable to represent a name, and then we can use that name for something within our block of code. So for example, let's pass in a name of whatever your name is. Let's say bro. We can pass in a value or a variable. So for this example, I'm going to pass in a variable called name. String name equals bro, and I'm going to pass my variable of name into my method. So if you want to pass a value or a variable to a method, when you call that method, within the parentheses, just list all of the values that you would like to pass to your method. The values or variables that you're sending to a method are known as arguments, and they can be confused with what's known as parameters. In order to pass some values or variables to a method, when we declare our method, we need a matching set of what's known as parameters. Think of these as the rules. In order to call this method, we need a matching set of arguments and parameters. Currently, these are not matching. We're passing in a string, but there is no matching parameter. So this is how to set up a parameter for a method. We're first going to begin by listing the data type of the value that our method is expecting. So we're passing in a string as an argument. So we need a string parameter. So we need to first list the data type, followed by a name for this value. Just to make it simple, I'm going to call this name. So we now have a matching set of arguments and parameters. And now, since we're passing in our name variable to our method of hello, our hello method now has access to a string variable of name, and it contains this value of bro. So now we can use this name for something. Let's display hello plus name. And when we call this method and pass in our name, it's going to display the word hello plus our name, hello bro. So with parameters, you don't necessarily need to keep the names of the values consistent. I could change this name to something else, like title, I guess. And then I will switch that around, and this will work just the same. So these don't necessarily have to be called the same thing, the argument and the parameter. You can change the name if you want. Even something like this would work too. I don't know why you would write it like that, but you can. So with methods, I don't know why you would write it like that, but you can. So with methods, you can pass parameter. You can change the name if you want. Even something like this would work too. I don't know why you would write it like that, but You can. So with methods, you can pass in more than one argument as long as you have a matching set of parameters. This time, let's pass in an integer value. Let's create an integer variable called age. Int age equals, and I'll set this to 21 this time. So within my hello method, I'm going to pass in my name and age as arguments to my hello method. However, we have a problem. If I attempt to run this, we do not have a matching set of arguments, name and age, and parameters. We're passing in a string and an integer, and our method has parameters set up to accept only a string. So we need to finish setting up the parameters for this hello method so that the arguments and parameters match. So we need an integer, and we will call this age, and then we can use this age variable for something. So within another println statement, let's display you are plus age. And now this will work because we have a matching set of arguments and parameters. And before we finish this video, I would like to explain return types. We can return a value back to the area in which we called a method. So for this example on return types, I think this can be best explained with a separate example. So I'm going to clear out all of this and create a new example. Let's say we have two integer values. Int x, this will equal maybe 3, and int y, this will equal 4. Well, let's create a method that will add these two numbers and return the sum, the result of these two numbers. So outside of the main method, let's declare a method static. Normally we would type void if we're not returning anything, but if we're going to be returning a value, we need to list the data type of the value that we're returning. If we're going to add two integers together and return the sum, we're going to list the return type as integer because that's the data type of the value that we would like to return. We would like to return an integer, and then we will list the method name. Let's call this add, parentheses, and then a set of curly braces. So we cannot normally finish compiling this because if we're listing a return type, we need to list a return statement. What do we want to return? Well, we're going to return an integer, but we'll have to get to that later. So let's begin by setting up the parameters for our add method. Let's say we would like an integer, let's call this x, and int y. So in order to call the add method, we need to pass in two arguments, two integers. So let's call the add method and pass in our variables x and y. And within the add method, we will add these two numbers together. We could store this within a separate variable, int z equals x plus y, and then we could return our value of z. So when we run this, what's going to happen? Well, it doesn't display anything. That's because when we return the value of z to this area in which we called our method, well, we're not currently doing anything with this value. So we could store this within a variable or display it directly to the console window. So let's store the sum within int z. Int z equals add x and y. So you may have noticed that we declared this variable twice, int z within our main method and within our add method. This is technically legal because they are known as what's called local variables. Int z is only recognized by anything within the immediate set of curly braces. It's known as a local variable. Our add method does not recognize this int variable of z, so we could declare our own to use, or you can rename it too. It doesn't really matter what you do. So we can store the sum of our add method within int z and then do something with it, such as display it to the console window, system.out.println z. So this will display the sum of 7. Another way in which you could write this, we don't necessarily need to store the value in which we're returning to a variable. We could just directly display it to the console window too. So within my print line, I'm going to call the add method and pass in x and y, and this will still display 7. Another way in which we could shorten our method is that we don't need to store the sum within a variable. We could just return x plus y. So let me clear this line, and we could return x plus y, and this would be valid too. So that's another way of writing this. Well, everybody, those are methods. They are really just a block of code that is executed whenever it is called upon. You can pass in values or variables known as arguments, but in order to do so, your method, when you declare it, needs a matching set of parameters. And then you could return a value if you need to. Instead of using the word void, just list the data type of the value that you're returning. So if you would like a copy of all this code, I will post everything in the comments down below. And don't forget to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys all about overloaded methods in Java. So sit back, relax, and enjoy the show. If you find this video helpful, please remember to like, comment, and subscribe. Your support will help keep this channel running. Alright, everybody, let's discuss overloaded methods. Overloaded methods are methods that share the same name, but they have different parameters. This is allowed because each method needs its own unique method signature. That is the method's name plus its parameters. They can share the same name, but they would need different parameters to give them each a unique method signature. Let's create a few overloaded methods, perhaps just a few add methods that will add some numbers together. Outside of our main method, let's declare a few overloaded methods. So for this example, we'll need these to be static. Let's return an integer, so the return type is going to be int, and this will be called add. And we will accept a few arguments, so we need to set up some corresponding parameters. Let's say int a and int b. And we will return the sum, return a plus b. So let's create another method, an overloaded method, also called add. Wait a minute, we have a problem. So we have two methods that are duplicates. Duplicate method add in type main. They both have the same method signature. They both share the same method name as well as the same parameters where they accept two integer values. There are two ways in which we can resolve this. The first is that we can change one of the method names, and this error would go away. But that defeats the purpose of overloaded methods. The other way is that we can change the parameters that we have for each method. Let's say we would like two versions, maybe even three versions of our add method. One that accepts two values, another that accepts three values, let's say int c, return a plus b plus c, and another that will accept four values. So we'll have int d, return a plus b plus c plus d. And then our problem went away. So let's test these. I'm just going to add a print line that states which overloaded method we're using. This is overloaded method number 1. And I'm going to copy this and paste it. And we'll change the second instance of this print line to this is overloaded method number 2. And lastly, this is overloaded method number 3. So let's try this. Let's say we have an integer, int x equals add, and we can pass in between 2 and 4 integers. Now I'm going to attempt to pass in a single integer value, but we cannot run and compile this because we do not have a matching method signature. We can pass in between 2 and 4 integers. So let's try this by passing in 2 arguments this time, 2 integer values, and then let's display the sum, the result. System.out.println, our variable of x. So we end up using our first overloaded method. This is overloaded method number 1, and this will display the sum, a plus b, which is 3. And let's try and use our second overloaded method. We need to pass in 3 integer values as arguments, and we are now using our second overloaded method. And lastly, we can pass in 4 integer values. And we end up using our third overloaded method, and we get a sum of 10. And with overloaded methods, not only are the numbers of parameters taken into account, but the data type for each specific parameter. So this time, let's create 3 more add methods, but these ones will accept double values instead of integers. So let's change any instance of int to double, including the return type. All right, and then I'm going to change
Hello, I'm Landon Schlungen, and today we are going to review JavaScript fundamentals by building a gradebook app. There's only 4 challenges in this project, and it's, I guess, review. So let's start this project. I haven't looked at it before. Let's see what's happening. There's 2 undefines here. We have a step 1. A teacher has finished grading their student's test and needs our help to calculate the average score for the class. Okay, so we have to do a getAverage function. Takes an array of test scores, and then it returns average score. Okay, yep. So average is calculated by sum of all scores divided by the total number of the scores. A couple of function calls have been provided. Okay, so this is how we can test it. So that's why it's returning undefined. This function has nothing in it. If I return 1, then these two will have 1 here, because we're calling the function and logging the result. Here we have the scores. We just have to loop them over and get the average. It gives us a tip, loop over them, add them all up, and then use the length property to divide that by the length property. Okay, so do a higher order function in JavaScript to basically do this on one line, but that wouldn't be in the style of this beginner challenge in FreeCodeCamp, so I'm just gonna do it how we would normally do it without the higher order functions. So I'm gonna go for int that'd be in like Java, let I equal 0, I less than scores out length, and I plus plus. Oh, and then I need semicolons here. I've forgotten how to code. I plus plus. And then inside of here, we have to add them all up. So scores of I plus equal. I'll just do let total equals 0 starting out. And then we're going to go total plus equal scores of I, because we're going to iterate through all the scores, add that to the total. For some reason, this is still grayed out. Maybe it's because we're not using it down here. And then we're going to do total, or let average equal total divided by scores.length. And that should get us our average, and I can just return average, like so. There we go, 71.7 and 85.4. Hopefully that's pretty easy to follow. And I wonder what we're going to do in the next challenge. Let's see if this is correct anymore.
change the number of the overloaded method that we're using. So 6, 5, 4, 3, 2, 1. Our first three methods only accept integers, and they will accept between 2 and 4 integers. Our next three add methods only accept double values, and they accept between 2 and 4 double values. So we could also pass in some double values to our overloaded methods. Let's change these to 1.0, 2.0, 3.0, and 4.0. And we will need to change the data type of our variable x as well. So double x add 1.0 through 4.0. And we are now using overloaded method number 6, which accepts 4 double arguments. In summary, overloaded methods are methods that share the same name but have different parameters. They can share the same name, but they would need different parameters to give each method a unique method signature. Some factors that are taken into account with parameters are the number of parameters, the data type, and the order of the values. So if you would like a copy of all this code, I will post all of this in the comments down below. Please don't forget to help me out and smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. Hey, what's going on everybody? It's your bro, hope you're doing well, and in this video I'm going to teach you guys all about the printf method in Java, so sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. One like equals one prayer for the YouTube algorithm. Hello all, welcome back to another video. For this topic, I'm going to be explaining the printf method. This is an optional method to control, format, and display text to the console window. Here's an example of the printf method, and this is different from print and println. With the printf method, there are two arguments we need to place within the parentheses of the printf method. The first is a format string, a string that you would like to display to the console window. And second, we can add either an object, a variable, or a value. To keep it simple for now, I just added a value of 1, 2, 3. So we can format some value and place it at some position within the string. The position in which we want to add this value, whatever it is, can be added to wherever we add a format specifier, which is represented by a %sign. Let's say we would like to add this value at the end of our format string. So we would add a format specifier at the end that is represented by the %sign. And there is a certain amount and number of combinations and characters that we can add after this format specifier, and this will format our value a certain way. If we simply need to display a decimal number, we're going to add a D. It's kind of like a secret code. That's how I think of it at least. So if we add a %sign and D, we will add this decimal value at this position within our format string, and that will appear down here. I could place this format specifier someplace else, and this value would be added to wherever I put this format specifier. So if I added this format specifier to the beginning of my format string, then this value will appear at the beginning of my string. So with the printf method, you need a format string and either an object, a variable, or a value. Depending on where you place this format specifier, the %sign, your value or variable will appear at this location. Think of it as you're replacing the format specifier with this value, and depending on the combination of flags, numbers, and characters after this format specifier, this is going to format and display your value a certain way depending on what combination of letters and characters comes after. Let's begin with conversion characters. This is a letter that appears after the format specifier, and the conversion character corresponds with the data type of the value that we're attempting to add. So D corresponds with decimal numbers, so we could add an integer at this location. So let's go over a few of the conversion characters that are available to us, but we'll need to create a few variables to do so. So let's begin with a Boolean. Let's call this my Boolean, and I will set this to true. We'll need a character, so let's say char my char equals, and then pick a symbol that you want to use. We'll need a string my string equals maybe your name. We'll need an integer, int my int and assign it a number. I'm just going to pick one at random, let's say 50. And let's add a double value. So double, my double equals maybe 1000. Okay, so these are not all of the data types that are available to us, but a few of the more common ones for beginners. So let's use the printf method and cover a few of the conversion characters. So we will need to use the printf method, system.out.println, printf, and let's just use the format specifier. So if we need to display a Boolean value, that would be percent then b for the conversion character to display a Boolean. And we need to add a second argument. That is the value that we're attempting to add. So let's add my Boolean. And we can now display whatever this value is. So for characters, that is actually percent %c. And let's display my character. Okay, so strings are percent %s. So let's copy this, paste it. That is percent %s. And this will display a string. Should probably get rid of that line too. Okay, and integers are d for decimal, but we've covered that already. So percent d for a integer. Let's display my int, which displays 50. And percent f for a double value. So that's for floating point numbers and double values. So let's display my double. So remember, with conversion characters, these are certain letters that follow the format specifier, the percent sign, and in order to display a certain object, variable, or value, you need a matching conversion character to follow after the format specifier. B for booleans, C for characters, S for strings, D for integers, and F for floats or doubles. Our next field is the width field, so I already created some notes on this. The width field sets the minimum number of characters to be written as output. So here's an example. We have a format string, and we would like to display a value that is of the string data type. So let's say at the end, we're going to add percent %s to display the string. We can set a minimum number of characters to display. So let's say we want to display at least 10 characters for this string. So before the conversion character, we can set a width, and this is a number. So if we want 10 spaces worth of room to display this string, we would add 10 or some other number before the conversion character. So before we display this, I'm just going to turn these lines into comments, and we will display hello plus my string, which states bro. So this prints a minimum of 10 characters for the name, including the length of the name. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, plus the space that was here already too. So you can set a width, and this will display a minimum number of characters to be written out. And if you set this to be a negative number, that's actually a flag that we'll get into in just a little bit. That'll actually left justify the text within the space that we're allocating to display this value. So this text is now left justified, but all of that empty space now comes after my text, my string. Next on our list is the precision field, and what this will do is set a number of digits of precision when outputting floating point values. These include the data types of floats or doubles. Here's an example. I have a format string that states you have this much money, and then we have a format specifier that will display my double. This is the default, so we need at least percent %f, and this will display 1000 as well as 6 zeros after our decimal. We can limit the amount of digits that will display after this decimal by using the precision field. So we write this before the conversion character. Let's say we would like to limit the amount of digits that we have after this decimal to 2 to represent cents. So I'm going to add 0.2 for 2 digits. and this will limit the amount of digits that will appear after the decimal portion. And if we change this to a different number like 1, well then this will only display 1. So that is the precision field. It will set a number of digits of precision when outputting floating point values. And lastly, we have flags. These will add an effect to output based on the flag added to the format specifier. Here's a few. We can left justify, we can output a plus or minus sign for a numeric value, we can have numeric values be padded with zeros, and we can separate large numbers by the thousands by using a comma. Let's try a few of these out. Let's copy what we have for our example for precision. So I'm going to copy this line, and let's get rid of the precision. So we have %f. Let's left justify this. So I'm going to set a width, maybe 20, and set this to negative. So this will left justify all of that. Although it's a little difficult to see, I'm going to get rid of the left justify, and this will now be right justified. So this would be useful if you need to line up a bunch of numbers. We can output a plus or minus sign for a numeric value. So I'm going to add plus f, and this should be plus 1000. If this was a negative number, like negative 1000, this should appear as a minus now. We can also pad our number with zeros. So let's set a width of maybe 20, and we will right justify it, so we do not need a negative sign, and we are going to add 0. So we now have a bunch of zeros before our number of 1000. And lastly, we can separate each thousands place with a comma simply by adding a comma as the flag. So %, comma, f. So at the 1000s place, we now have a comma. So that is all what the printf method is. It's an optional method to control, format, and display text to the console window. We need at least 2 arguments, a format string, as well as either an object, a variable, or a value. We can add a format specifier within this format string and add a combination of characters and numbers to format our variable, value, or object a certain way. So that is an intro, more of a crash course to the printf method. If you would like a copy of all this code, I will post everything in the comments down below. This video was a lot of work. Feel free to smash that like button, drop a comment down below, and subscribe if you'd like to become a fellow bro. How's it going, everybody? It's your bro. Hope you're doing well. And in this video, I'm going to teach you guys about the final keyword in Java. So sit back, relax, and enjoy the show. Make sure you like, comment, and subscribe. 1 like equals 1 prayer for the YouTube algorithm. Okay, ladies and gentlemen, I'm going to be teaching you guys about the...
Anyway, yeah, it looks like it is.
Hey, welcome back.
The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
So now we have this last exercise. I'm creating a MySum. I'm going to go through all of these values, and you guys have already told me what values these are. 5, 7, 9, not 11. And I'm going to add to my sum, so I'm going to keep a running sum, adding all of these values together. Okay? So the very first time through the loop, my sum gets the value of 5. that's this line here. The next thing I see inside this loop is an if statement. If my sum is equal to 5, that's true. So I'm going to go inside this if statement. The next thing I see is a break. If I see this break, am I evaluating this line or not? No, exactly. Because whenever Python sees break, it's going to say, I'm going to stop right here, exit out of the loop that I'm currently in, and go to the statement that's immediately right after it. So what this is going to print is my sum. And
Hi, I'm Sarah from Codecademy, and today we're going to talk about a fundamental concept in computer science: loops. Life, like programming, is full of repeating routines and subroutines. Every day we wake up and brush our teeth. We don't just brush one tooth, we brush each tooth in our mouth until we've brushed all of our teeth. In programming, when we know we're going to use a routine again, it's good practice to put that routine into a function so that we can reuse it. When we want to repeat a function or subroutine multiple times in a row, we can use loops. The other day, I wrote some instructions for frosting a cupcake and put them in a handy function, frost cupcakes, so that I could reuse them whenever I needed. Say I need to frost 3 cupcakes in a row. Okay, no problem. I can just call my function 3 times, right? But what if I needed to frost 5, 10, or even 1,000 cupcakes? Here's where a loop saves the day. A loop allows you to continually execute the same code multiple times, or loop through a routine, until a stopping condition is met. There are different types of loops, and each programming language has their own syntax. But all loops have one thing in common: a stopping condition. This condition is checked every round, and the loop will continue to run until the condition is reached. If our goal was to frost 4 cupcakes, the loop stopping condition would specify to continue to frost cupcakes until 4 cupcakes have been frosted. So our loop would run frost cupcakes 4 times, giving us 4 fully frosted cupcakes. Loops allow us to tell the computer where to start and provide a condition upon which to stop, all in a few easy-to-read lines of code, which is super sweet.
For loops, you can run the same code multiple times using a loop. The most common loop in JavaScript is called a for loop because it runs for a specific number of times. Here's the structure of the for loop. You always start with the word for, and then you're going to have something in these parentheses. You usually have 3 items. There's the initialization, and then you put a semicolon. Then you have the condition, and then a semicolon, and then the final expression. And then whatever's going to run in the for loop would be in these curly braces over here. Now, all of these things are optional, but you have them in most for loops. The initialization is run just once to set up the loop variable. And every time the loop is run, the condition statement is evaluated at the beginning. The loop keeps going until the condition is false. And then the final expression is evaluated at the end of each loop iteration and is usually used to increment or decrement your loop counter. Let me give you an example of this. So in this example, first, outside of the for loop, we're going to create an array called rArray and set it to an empty array. Now we have the for loop. This is the initialization. We are going to create the variable I and set that I equal to 0. Now here's the condition. I is less than 5. So we are going to keep running the for loop while I is less than 5. So as long as I is less than 5, we'll continue running this for loop. At the end of each run of the loop, we are going to increment I. I plus just means we're going to add 1 to I. So it's going to go through the loop the first time. It's going to run this code within the brackets, and it's going to push I onto the array. And remember, I starts off with at 0. It's going to push 0 onto the array. and then it's going to increment I. Remember, it does this at the end, so now I is 1. It's going to go through, it's going to push 1 onto the array. It's going to go through, push 2, push 3, push 4. After 4, we'll increment I to 5. Before the for loop goes, it's going to check, is I less than 5? No, I is actually 5. I is not less than 5. So as long as this. So in this example, first, outside of the for loop, we're going to create an array called rArray and set it to an empty array. Now we have the for loop. This is the initialization. We are going to create the variable I and set that I equal to 0. Now here's the condition. I is less than 5. So we are going to keep running the for loop while I is less than 5. So as long as I is less than 5, we'll continue running this for loop. At the end of each run of the loop, we are going to increment I. I plus just means we're going to add 1 to I. So it's going to go through the loop the first time. It's going to run this code within the brackets, and it's going to push I onto the array. And remember, I starts off with at 0. It's going to push 0 onto the array. And then it's going to increment I. Remember, it does this at the end, so now I is 1. It's going to go through, it's going to push 1 onto the array. It's going to go through, push 2, push 3, push 4. After 4, we'll increment I to 5. Before the for loop goes, it's going to check, is I less than 5? No, I is actually 5. I is not less than 5. So it's only going to push the numbers 0 through 4 onto the array. Let's check that out by console.logging it. So yeah, we got the array 0, 1, 2, 3, 4. You can also use a break statement to break out of a loop early. So now I have if I is more than 2, break. So if we run that, it's just going to put 0, 1, 2, because after 2, I is more than 2, so it breaks out of the loop, and then we're done with the loop. Now it's also common for loops to iterate through an array. So if an array already exists and has some items in it, we can loop through and console.log or print out each item in that array. So we're going to initialize I to equal 0 if I is less than r.length. So that's the array. And length is the length of the array. So if I is less than the length of the array, we are going to continue going through the array. So once we get to the end of the array, we'll be done with the for loop. At the end, we're going to increment I by 1, and we're just going to console.log r, and then we just put the I variable as the index that of the array that we're trying to console.log. So first we're going to get the array index 0 because I will equal 0, and index 0 will be 10. Then we'll do index 1, 2, 3, 4, because each run through the array, we're going to increment I up 1, and that's going to go to the next index of the array. If we run that, see, we got 10, 9, 8, 7, 6. If you have a multi-dimensional array, you can use nested for loops to loop through both the array and any r.length. More than 2, break. So if we run that, it's just going to put 0, 1, 2, because after 2, I is more than 2, so it breaks out of the loop, and then we're done with the loop. Now it's also common for loops to iterate through an array. So if an array already exists and has some items in it, we can loop through and console.log or print out each item in that array. So we're going to initialize I to equal 0 if I is less than r.length. So that's the array, and length is the length of the array. So if I is less than the length of the array, we are going to continue going through the array. So once we get to the end of the array, we'll be done with the for loop. At the end, we're going to increment I by 1, and we're just going to console.log r, and then we just put the I variable as the index that of the array that we're trying to console.log. So first we're going to get the array index 0 because I will equal 0, and index 0 will be 10. Then we'll do index 1, 2, 3, 4, because each run through the array, we're going to increment I up 1, and that's going to go to the next index of the array. If we run that, see, we got 10, 9, 8, 7, 6. If you have a multi-dimensional array, you can use nested for loops to loop through both the array and any subarrays. Let me show you an example of that. Okay, so let's look at this. We have this array variable, which is a nested array. So there's one array, there's the beginning of the array, and there's the end of the array. And inside the array are 3 other arrays. So inside the first array, here's index 0, here's index 1, here's index 2. And in each of those indexes is another array. So we have index 0 and index 1 in each array. So you can use nested for loops to loop through both arrays. Here's our first for loop. Here's the end of that. And then here's our nested for loop. So we're going to initialize I to 0. If I is less than array.length, and the length of the array, see we have 1, 2, 3. So the length of the array is 3. But now inside the nested for loop, we have to initialize the variable differently. So now instead of I, we have j. Now if j is less than array index I.length, when we're looking at the array index I.length, that's the first item in the array, which is the first array within the array. So now the length of this is just 2. We have 1, 2. So we're gonna increment j. So we're gonna run through this first for loop, and inside the first for loop, we're basically gonna go into the first array. And now we're gonna console.log each item in the first array. We're going to array index I, index j. So the first index is what index in this first array, which would be, if we're going to index 0, that's this, and then the index j will be what index in the second array, in the nested array. So we would get index 0, index 1 for j. It's going to go through this inner for loop to get both indexes in the first array. Then it's going to go back to the outer for loop to bump up to this next array. And then we're going to go through the inner for loop again to get both indexes in here, and so on. If we console.log that, it's going to say 10, 9, 8, 7, 6, 1, 2, 3, 4, 5, 6. So the first 10, 9, 8, 7, 6 was from up here, and then we have the 1, 2, 3, 4, 5, 6 from down here. Well, those are for loops and nested for loops. Thanks for watching. My name is Bo Carnes. Don't forget to subscribe, and remember, use your code for good.